Welcome everyone. Today we will see how we can perform binary search in a sorted array. Okay. So before writing code for binary search, okay, actually you can search element in an array in two way. Either you can use linear search or binary search. But linear search you can use in unsorted array, but binary search is preferable to use in a sorted array. And linear search, if you perform, then it will give in order of n time complexity, but binary search will give log n time complexity to search whether a given element is present in your sorted array or not. So most important thing here, binary search is only preferable and you can only use in sorted array, otherwise it is not useful. Okay, so let me start writing code. So here you can take one example. Let's say I will take some random number 1, 3, 5, 11, 13, 17, right? And then let's say 23, 29, 31, okay, etc. So this way you can, uh, take some random number, integer number. So to find the length of an array, it's very simple way. What you do? Just take, you know, the array and divide this by the first element size of an array. Okay, or I mean not with one, any size from any element you can devise. Let's say array index is 0, you can put 1, you can put, means from any element size and the size of an array you can divide, then it will give the length of array, basically the number of element present in an array. Okay, then I will take, let's say, index, one integer variable, and I will take one element. Okay, and let's say I will hard code, let's say 29, I will find whether it is present or not. Okay, so here what I will do, I will pass this, I will take one function, let's say binary search. Okay, and I will pass this array. Then what I will pass, let's say I am assuming the base index is 0 and the last index is n minus 1 because I have already taken n by n, and I will pass this element as well. Okay, the element which I want to search. So let me define this function here. So it will return int integer, and then I will have this binary search function. I will take integer array as it is. Okay, then I will have this, let's say the name I will take is, let's say, beginning. Okay, and let's say here I will take end, basically beginning index and end index, and I will take here element. Okay, so let me create one middle integer variable. So I want to find middle of, I will tell you how it works, but let me write first. So here I will compare if beginning is less than equals to end or not, right? And every time I will find middle. Okay, so how you can find is, it's like beginning plus, you just subtract end index from beginning index, divide by 2 and add with the beginning will always have 0, right? Because we are passing the 0 hardcode value. So for next time, right, here what you do, you will compare if the first time itself, or if you will compare array of middle, are you getting the same element which which you want to search? If it is true, then simply return middle. Fine. Now, if it is not, then so let's compare if array of middle is higher than the element you want to search. Then what you need to do? So let me explain some scenario here. Let's say you want to search 23. Just take here main example. Let's say you want to search 29. So what is the number of element here? 3, 3, 6, 9. So middle element is 13 perhaps. Okay. So 13 is not greater than 29, right? So this will not satisfy. So for example, so what you do if in this case, if array of middle element is greater than the element you want to search, you just restrict your search. How you can restrict your search? You don't need to go beyond the middle element because your array of middle itself is the highest, higher than your element you are searching. So what do? You simply restrict end equals to middle minus 1, correct? And else part, what do? Even no need to have this because one statement is good enough. Okay. So in else part, what do? Beginning equals to middle plus 1 means now what you are doing is here in this case you are making sure the middle element should be the last element, means you are searching from here till here, and in this case you will be searching from here to here, right? So now if while loop is over, right? So what you need to do, you simply return -1, means element is not found. So let me write some printf statement quickly here. You need to compare first, right? So if index equals to -1, then what do? Printf not found, right? Else what do? Printf found at, let me write like percentile d location, and I will print index as well. Okay, so let me run this and see what all error we are getting. So found at 7 locations. So first time itself it run. So see, if you see, this is your which element we are searching, 29. So this is 0th, first, second, third, fourth, fifth, sixth, seventh. This is found at 7th location. Let me remove this and let me search for 49. Not found. Let me search for 11. Okay. So run this. Found at third location. So 0, 1, 2, 3. So this way you can have code to search using binary search in a sorted array. You can search an element using binary search in a sorted array. Okay. Thank you.